Ladies and gentlemen, we are now very pleased to welcome back to the demonstration area Magnum Venus products. MVP is a global manufacturer of fluid movement and production solutions for industrial applications in composites and adhesive markets. Charles Tur is a renowned expert in resin transfer molding and infusion technology. And for this last demonstration session, Charles will do a thorough review of various techniques, best practices, and advanced methodologies to ensure optimal results in your molding processes. You may ask him questions after the demonstration. La démonstration va être en anglais. Si vous souhaitez avoir une traduction directe en français, n'hésitez pas, messieurs et mesdames, de demander un casque auprès des hôtesses. And now, Charles, the demonstration floor is over to you.
Thank you very much, and welcome back for the last demo of this GC. So what I'm going to do is mainly on the presentation is to show you a little bit an overview of everything and what I believe is important in closed mold. So just briefly to introduce MVP, we are on the market more than 80 years. We produce all different kinds of machines for composite, injection machine, adhesive machine, spray up, gel coat, filament welding, and a 3D printer for composite. So the composite customer demand is, of course, time saving, produce better and faster, environment, decrease waste and energy saving, if possible, labor, easy job, and less possible mistake. We find that after COVID, it's hard to find workers, so we try to develop process where it's easy to make the job and to avoid mistake. So trimming a part after demolding use a lot of energy and take a lot of space. So that's why we work on that, and that slows down, of course, the production. So the solution is to demold a finished part, as we have here, and to produce on self-cleaning mold. So forget to change all the pipe all the time, full of resin, the valve, the connection, and so on. No, we have to think about it when we design the process that the resin will never reach the vacuum channel or the vacuum pipe. So when demolding a part, the mold and countermold must be clean. No work on the flange to remove resin or gel coat. It has to be self-clean. No vacuum pipe to change, as I explained, more ready to go back directly in production. Why? Because what is the main problem? When we clean the flange of the mold and we try to remove resin, we scratch a little bit and we remove the release agents, which are most of the time semi-permanent release agents. So what we have to do, we have to apply a little bit more release agent on that area. And the point is sometimes we put that, and when we apply the gel coat, we have self-release of the gel coat because of too much release agent. So it's why it's also very important to take care that we don't have to clean anything. The release agent is the most important step in closed mold. That's very important to find the right products and to use it. We can use also flange protector for the gel coat and the resin stopper to not contaminate the pipe. So when we talk about semi-permanent release agent, there is plenty of semi-permanent release agent. The one we have used this week is the one from Axel. There is plenty. We have cleaner to clean the mold, sealer, and release. And according if it's gel coat, non-gel coat, DCPD resin, we have different. It's very important to ask your supplier about it. Then, by the technology we show here, where we are able to bond composite on silicone, that was our last demo this morning, we are able to make a flange protector. So instead to tape and to plastic, all the flange will take time, then it's better to do what you see on the screen. You have a flange protector, you spray your gel coat, you remove it. But the problem is that if you do that in composite, the gel coat will stick on that, and then it's complicated to clean. That's why now we have the possibility to have a combination of composite and silicone. So then, by an air gun, you remove the gel coat when it's cured, and it's self-clean. So much easier to do. We cannot just apply the silicone, because the silicone will fly out when we spray the gel coat. So composite and silicone help to that. And as you can see, I make a little return on the vertical area. Like that, I can automatically locate the protector when I spray the gel coat. So the resin stopper is to avoid that the resin will reach the vacuum pipe. So for that, we use mainly peel ply or core mat, which is perfect for that. The most important is that you use a resin stopper that stop the resin, but that do not stop the vacuum. That's very important. So some say that you can use a toilet paper or something like that. Is bullshit. It has to be a material that slows down the resin or stop the resin, but let the vacuum pass, because you keep pulling the vacuum until the resin gel. Peel ply or core mat. So then on the flex molding process, we have a silicone membrane, as we have here. That's the silicone membrane. There is two possibilities. We adapt the process for an existing mold. It will work, but I'm not sure you will make money. The best is to design the mold for the process, to think about it when you even design your pattern, to be sure that you will save time on each step of the production. That's our recommendation. Then, after that, according to the part, like here, if we have sandwich construction and so on, we adapt it. So we make some tests about resin infusion to decide about the location of the resin channel, and we just build it and make it. Here, for example, we need a pattern to pre-cut the foam. That has to be done on the process when we build the bag. When we calibrate the part thickness, we automatically make the pattern. So that can be done by CNC if you have everything computering. If not, you do it by hand with a wooden template. But it has to be done to be sure that every time you will have the same size of foam on the same location. Then after that, it's very easy to success in production. But don't try to bypass all these details, because this is where it's better to spend a little bit time building the mold and the membrane properly to save time in production than to say, okay, I make a quick membrane and I will see. That's a mistake, and in production, by the feedback we have, it doesn't work well. Here you can see we demold the membrane and everything is clean, and we demold the part, is clean. Part injection. Injecting resin from the mold center to border give the possibility to stop the resin. This is what we see with flex molding. We are able, you see this morning I just grind a little bit, but the part is directly finished. That's the part we have injected yesterday. No resin channel visible and no need to trim the part. Why? Because when we design the mold, we think about it. We say, okay, we have to produce the parts, we would like to save time. How the operator will load the glass? Where is the line of the end of the part for them to see? Just a line is not good, because when you spread the gel coat, then the line disappears. So we make a step on the mold, the step of the thickness of the part, like that. They know exactly how to load the glass. That helps to save a lot of time in production. Little details. And after that, we can use the collapsible resin channel, raw material with integrated resin channel, leaving visible resin channel. So that's the collapsible resin channel. We talk about it the whole week. Under vacuum, into the mold. So this is how it's working. We have the fiberglass. We load the membrane on the top of it. We apply the vacuum to help the resin flow, and the second vacuum on the resin channel. We collapse the channel, we inject the resin, and just before we finish, we stop putting the vacuum into the resin channel, and it comes back flat. That's why we don't see any line on the backside of the part. No waste. That's also very important. No waste. Because we stop putting the vacuum into the resin channel, we have to calculate that the resin which is on the resin channel will help to finish to fill the part. So we don't stop to inject when the part is filled. We stop to inject when we have injected the right quantity of resin. That's why it's very useful to use an injection machine with a predeterminating counter. We just inject the right quantity of resin, and that's it. Like that, you can control the production and the cost of the production. We always put the same quantity of glass, same quantity of resin. So we have different process in closed mold. Here, for example, we have light RTM. That's the way we inject the part from the border to the center. Classic light RTM, using for years and years and years, but unfortunately, we have to trim out the resin channel. Then we can go for fast flow light RTM, as we have explained, where we incorporate all the resin channel on the counter mold to decrease the distance of the resin flow and to inject the part faster. As you can see, that was in India on the demo at the ICRP, and that's the part we demold from the mold. Directly finish. So, as I explained, you can see the step on the mold of the part border. Like that, we know exactly how to stop the glass on the part. We don't waste time doing that, and the people don't have to come with the scissors on the mold to damage the mold. We have a pre-cut glass, we load the glass, it's down. Then we can use a fast flow technology, as we explained. We build a counter mold, which is silicone instead of gel coat. Then we come with the composite on the top of that, as we have developed a unique solution. You have to know that the most complicated things when we make development is not the development itself, because we always find a solution. The most complicated is to make it easy, to make it simple, to be sure that everybody can do it. And that's another story. I make this ID works in 1 week, but it takes me 6 months to find a solution that everybody can do it. So, as you can see, we have loaded the glass precisely, resin stopper where is needed. We put the resin stopper only when the resin arrives last. That's it. No need to put all around. And we close the mold. 2 vacuum, that's very important. 1 vacuum to help the resin flow. When we use polyester resin, the resin contains styrene. So we cannot pull the full vacuum, if not the styrene will be bubbling. So we use like 60, maximum 70% of vacuum. But when we apply the vacuum into the resin channel, it cannot be the same vacuum. Because if you have the same vacuum both sides of the silicone, nothing will happen. The vacuum you pull on the resin channel has to be higher than the vacuum you use to help the resin flow. That's why we use a medium vacuum and full vacuum into the resin channel, to be sure that we collapse it. And then when you demold, as you can see, we demold a direct finished part. So the part we use today is part for transportation. Why? Because we work recently with a new kind of resin, which is a PU resin. PU resin from Dow, called Voraforce. That resin has a fantastic impact resistance. You can come with the hammer, try to destroy the part, doesn't move. You give a lot of stiffness on the part, so you can make a lightweight part. You can decrease the weight of the part by 25%, which is very interesting for all transportation markets, especially buses, vehicles, cars, trucks. So it's a 3 component. You have the polyol, the ISO, and a catalyst, which is a special catalyst for PU. That's developed by Dow, and we have developed the process to be able to use that resin, because this resin has 2 main points, which are 600 centipoise and 5-minute gel time. So it doesn't matter the size of the part, it has to be injected in less than 5 minutes. So for that, we have developed a machine, which is a 3-component machine, and the process to be able to use and to inject part in less than 5 minutes. So this is what we do here. We have a large part, 6 square meter part, that we inject in less than 5 minutes. So we close the mold, inject the part, and get that. Also, another advantage of that resin is that resin has no shrinkage. You can produce Class A surface finish, 0 shrinkage. So this is a customer in Poland who do the same. As you can see, silicone, composite on silicone, demold the counter mold, test the mold with the vacuum channel, close the mold, and inject the part. Same things. Now, if we talk about light RTM for production, here it's interesting. You see the part, and the size of the part we have to produce is a large part. We want to inject the part a little bit faster. So if we try to inject the part all around on the resin channel, it will take a long time to go to the middle. And because of the corrugated form, you cannot guarantee that the resin will arrive exactly in the center at the same time. So because these 2 parts bonded together, there is no problem to see the resin channel on the part because they are bonded together, we will not see it. So that's why we decide to inject the resin like that, even if it's lighter TM. The red line is the injection resin line, resin channel, and the green light is the vacuum channel. Because of that, we decrease the injection time by 3, and we guarantee no trapped air on the part. So sometimes we have to think different. See the part? You can see the resin channel on the flat part, and the bottom part, which is corrugated, will be bonded on the top of that. Nobody will see it. So this is where are located the resin channel. And there is no problem. So we have used this idea to produce another part. Here we are in Spain, a company Poltank, who produce a filter for swimming pool. For large swimming pool, small swimming pool, city swimming pool, doesn't matter. And they had an issue to produce the part which is in the middle. The part which is in the middle have around 16 bolts. So they have to produce the part, they have to make the hole, they have to put the bolt, they have to laminate on the back. It takes a lot of time. And then they have to trim the part. The part is 15 millimeters thick. So they wanted a solution, instead to produce everything by hand, where we can incorporate directly the bolt when we inject the part. So I look at the part, I see that, and I make a test. So I make a part section, I incorporate the bolt into the laminate, close the mold, have a contour mold, and make a visible resin channel in the center. Nobody cares about it because after that it will be on the filter, nobody will see it. But I inject the resin from the center to the border. And because of that, I'm able to stop the resin on the part border. So this is what we have done. We demold the part. And as you can see, there is no need to trim the part when we demold. So they make the mold. That's the contour mold. We use also what we call vertical flange. So at the external of the mold, when you have too much glass, it's complicated to compress all the glass and to close the mold. And then you start to play with clamp, it's boring. So what we do, we continue the extension of the female mold by a vertical section. And we have a second wing seal that will slide on it like a piston. And then we close until the second one touch, and then close the mold. So we locate also a Teflon insert to load precisely on the right position and the right place the bolt. So when we calibrate the part thickness before we build the contour mold, we pull all the bolt, all the calibration. As you can see, we stop the calibration precisely on the part border. Then we laminate the mold, we demold, we set up the contour mold, we add the seal and so on. And we are ready for the production. So for the production, we load the glass, we load the bolt properly, everything is pre-cut. We close the mold. When we close the mold, the contour mold push down the glass on the right position. And we just inject by one injection port along the part, the center of the part. And when we demold, as you can see, the part stops precisely where we want. We just have to remove the peel ply, that's it. And then we have a direct finished part with the bolt that we don't need to trim. Imagine the time saving doing that. This is where it's important to focus on production. So we don't adapt the process for the mold, we design the mold for the process. Here we are again in Spain, we produce ping pong table. Outdoor ping pong table. Sandwich construction, integrated metal structure, and again, need to reduce waste, injection, everything at the same time, and almost no trimming. So that's the calibration we have done with the foam. And in this case, we leave only 1 millimeter between the resin channel and the part border. So we build the contour mold after we calibrate everything. Also the metal structure that you can see in the middle. Then we demold the contour mold, we set up the contour mold with the seal, we check the location of the metal structure. As you see the pipe has to be closed on the edge, because if not the resin will flow inside, which is not good. So we close it with a silicone and a little part. Then we load the glass. We have to calculate the glass that we have no waste. So the width is 125. So we turn around the part. And at the junction, instead to make an overlap, we put the injection mat border to border, and we put a band of continuous filament mat on the top of it. Then we load the wood. The wood is a special wood for the ball. And the metal structure, and we put the glass on the top of it, and we just inject the part. And that's the part when we demold. And you can see the cross-section when we cut the table. Everything is working because we think about it since the beginning. We design the mold and the countermold for the process. Then we have shown this week also the SVB seal, when you use a part with a plastic bag. Then we show how to seal a plastic bag without tacky tape. So the part we have done together is the part which is here, where we use the collapsible resin channel in the center, with the plastic bag on the top, that we seal with the SVB seal. And then we inject it. And when injecting the part, I demold the part this morning. We get that part. No air bubble, everything under control. So it's just to show that there is different solution for different application according to what you want to do. Of course, you can make a full silicone membrane, but you can use the combination of silicone and plastic bag. Why we want to work with a tacky tape? Tacky tape is a fantastic product. We don't go against the tacky tape, and we believe that people will go for both and large part. We'll still use the tacky tape. That's not the problem. We just find that people has hard to find workers who take care to not have any leak. So that's why we develop a process where we can secure. The most important for us on the SVB seal, the name is Secure Vacuum Bag Seal, and the most important for us is secure. That's the way we were producing the swimming pool 10 years ago, 15 years ago. And that's the way we produce the swimming pool today, where the only consumable is the plastic bag. So this is the reusable seal. I will go a little bit fast. We have a groove. We load the glass. We come with the resin stopper. If we need, we put a vacuum channel. We come with the plastic bag. We push down the plastic bag into the groove with the first part of the seal. We trim out the excess of plastic, because this is where the leak comes from. And then we come with a second part, which is a lips, to close it under vacuum. And when you pull the vacuum here, you guarantee zero air leak. Because it's impossible to have air leak, because we pull the vacuum where the air can come from. So that's the way we work. We load the plastic bag. We don't care anymore about the folders. Folders is not a problem anymore. We load the bag. We are able at this time to apply the vacuum in the middle, but of course we leak. We trim out the excess of plastic. Then we come with the second part of the bag, of the seal, sorry. We apply the vacuum. And the part we inject like yesterday, we inject the part in 5 minutes, and it's 1 hour's gel time. So during 1 hour, if you have any leak, all the air will come on the part, which we don't have. And then we have the possibility to use all kinds of accessories that we develop, injection valve, PV sensor to control the internal pressure during injection and so on. So all that are available at MVP. And the same as yesterday, I use no gel coat and there is no air bubble on the part. So everything is based on the fact that on the flange of the mold, we have a groove. If you put a groove, which is standard groove, you can do everything. You can do light RTM. You can do silicone bag. You can do SVB, which is plastic and silicone. You can do fast flow light RTM. So our recommendation, when you make a mold for closed mold, put a groove on the mold. Like that, after it, you can decide about the process. Everything will work if you have a groove on the mold. We go to customer, they say, oh, I have an existing mold, it's complicated to make the groove, so we ask them to make an extension. If you go to build a new mold, put the groove on the mold. This is the seal we have designed for that, and that seal is completely reusable. So you make a mold, you remove the seal, and you make another mold with it. So this is a two-part seal. for the flex molding process that you burn. There is some rules to respect, like a 1200 millimeter diameter, to be sure that you can pass with the seal. And see that with that mold, you can have silicon membrane, you can have SVB seal, you can do everything, RTM, fast flow, everything. And it passes all the details or any kind of part. So at MVP, we do organize training. We can do the training to your factory, or you can come to us, where we can overview all the different processes. We don't sell any process at MVP. We sell equipment. The processes are for free. But there is things to learn to make it work. And this is what we teach to the customer. So we do that all around the world, but we have also a workshop in the south of France. And the first people we train at MVP are our distributors. Why? Because it's nice to be important, but it's more important to be nice. We don't like the customer to wait after us. So if you have a local distributor, he will know how to support you and how to help you. That's very important for us. So here, for example, is a training in India, making a light RTM component for buses. Here we are in Egypt, making light RTM, making flex molding, making sandwich panel for refrigerated truck. Here we are in Mexico, running training for distributors, and we give a diploma at the end of the training. Here we are in France, where we do a training with our distributor. And as you can see, we have all the equipment, all the material. Here, this is a job done by our distributor in Netherlands, City Platen, to make that kind of part. So he has made by himself all the resin channel and then produce for the customer who produce the part with it. So our distributors are able to do that. And just for your information, the job that we do is not only for customer. I have a workshop in south of France, and I can tell you that half of the people who come at this workshop are suppliers and not only customers. Why? Because we need to have a close relation with supplier to develop products, but to develop process. We need to know what we can do. For example, we have received Elkem silicone. They came to us with a silicone which was not good. It was 5-minute gel time, not texture drop, was not good. So we showed them what to do, and they developed the perfect silicone for this application. This is a close relation we have. Then after that, we can recommend it because we know what we talk about. It's the same for the glass. We have worked here with Owens Corning for the glass. It's the same for the resin suppliers. Sometimes we have project for the PU resin, for everything. We have close relation with supplier, and that is very important. Thank you very much for your attention. That was the last demo of the GSA 2024. It's finished. If you have any question, feel free. Remember, we have distributor in all the country. We have a booth here. You can ask everything, so feel free. I will let my colleague to talk.
Yeah, thank you so much, Charles. Charles has been a fantastic 5 demonstrations during the JEC, giving incredibly valuable information. He is an expert. Once again, ladies and gentlemen, if you have any questions, quick questions, we have a microphone here. Anyone curious? Okay,
No
don't
problem.
hesitate to come and see Charles now if you would like to speak to him in person, or visit the MVP team at their stand at 5U58, Hall 5U58. They will be here still this afternoon. And thank you once again, Charles, for all of the demonstrations, all the fantastic information. You've had a full house every single time. You can see your expertise, your knowledge, and it's nice to be important, important to be nice. I'll remember that. Great tagline. Thank you for your attention, ladies and gentlemen. Our very last demonstration, live demonstration of today will be happening back here at 2 o'clock with Thermwood. So we would love to see you again if you would like to come back. Otherwise, thank you very much for your attention and enjoy the rest of the show.